Okay, so this is what we have learned so far about the definition of vector, its notation in the form of column vector and basis vector, unit vector, the magnitude of vector, its position vector, and vector displacement. Okay, you have learned about all these, and you have done some of the exercise that I have given you last week. And by the way, I have given you the answer key for that. If you want to check whether you do it correctly or not, you may see the answer key that I upload in the Scholar. Okay, now let's see a different operation of vectors. Okay, now let's see the first one, the sum of vectors. Okay, the sum of vectors. There are three methods to find the sum of vectors geometrically. The first one is the triangle method, or the one that we call head to tail method. Let's just say that I have vector u and vector v, and I want to add these two vectors. So the way to do it in triangle method is that you place the vectors with the head of the first vectors. Let's just say this one, the head of vector u. You connect with the tail of vector v. This is the head of vector u, this is the tail of vector v. You connect it, and then the resultant vector, or the addition vector, is that connect the tail of vector u, or the first vector, to vector v, the head of vector v, or the last vector. So this is the green one, is the resultant vector of these two vector u plus v. The second one is parallelogram method. Okay, let's just say that I have a vector u and vector v. So in this method, you place both vectors u and v at the same initial point. Okay, you place both vectors at the same initial point. And then you complete the parallelogram, making parallelogram where this one is parallel to vector v, while this one parallel to vector u, in the same direction and the same length. Okay, then you have the resultant of vector u and v is this one. This is the resultant of vector u and v using parallelogram method. If you have more than two vectors, we use polygon method. This method is similar with the first one that we did. It's head to tail method. Okay, let's just say that I have three vectors u, v, and w. Okay, using head to tail method, we place vector u like this, and then we connect the head of vector u with the tail of vector v, and then connect the head of vector v with the tail of vector w. Okay, and the resultant vector of this is when we connect the tail of vector u, or the first vector, with the head of vector w, or the last vector. Okay, so this is the resultant vector. Okay, this is the example of adding vectors using polygon method. Let's see that we have four vectors here, a, b, c, and d. Okay, if we connect all of this vector using head to tail method, we can see that the resultant of this vector is equal to 0, where the tail of the first factors and the head of the last factor is coincide, like this. Okay, the difference of two factors or factor subtraction. Okay, how to subtract factors? Subtracting a factor is the same as adding it with negative factor, like this one. Let's just say that I want to subtract factor u and factor v. Okay, it's the same like adding factor u with negative factor v. Okay, so let's just say that I have factor u, factor u, and this is factor v. If you want to subtract, it's just add with negative factor v. Negative factor v, it means the same length with factor v, but the opposite direction, like this one. So, the subtraction factor of these two factors is that using like triangle method, it's like this is factor u. The head of factor u connect with the tail of negative factor v, like this one. So this is the resultant, or factor u subtract factor v. Okay, second method of factor subtraction or the difference of two factors is parallelogram method. This one is similar with the sum of two factors using this method. Okay, like I said earlier, in subtracting two factors is the same like adding two factors with a negative factor. So like this one. Again, if I have like factor u and factor v, and this is the negative of factor v. Okay, if you subtract it using the parallelogram method, you put the tail of both factors in the same initial point. You make a parallelogram, and then this is the resultant. Factor u subtract by factor v using parallelogram method. Okay, so we have learned how to find the sum and the difference of two factors geometrically. So now let's find the magnitude of the sum and difference of two factors. Okay, let's just say that I have factor a here and factor b, whose angle in between is alpha. So if I want to find the resultant of these two factors using triangle method, okay, I get this triangle where the red factor, this one, is a plus b, or its resultant, and the angle become this one, 180 minus alpha. Okay, so I have this triangle. This one is a, this one b, and this one a plus b. And the angle between this and this is 180 minus alpha. Okay, so how to find the length of a plus b? Okay, in order to do this, we must remember the lesson that we learned in the previous chapter, the cosine rule. Okay, remember the cosine rule? It said that a square plus b square equals b square plus c square minus 2bc times cosine alpha, where alpha is the angle opposite with the side A, or in between side B and C. Okay, so in this case, if we want to find the magnitude of a plus b, using this rule, we get a plus b equals to square root of a square plus b square minus 2 times a times b cosine 180 minus alpha. Okay, because the angle in between is 180 minus alpha. Remember that 180 minus alpha is negative cosine alpha. So the formula for this become like this. Okay, so this is how you get this formula for the magnitude of the sum of two factors. Okay, now how about the difference of two factors? Okay, the formula is similar with the sum of two factors. So if A plus B, this one is plus. If A minus B, this one is also minus. Okay, and alpha is the angle between factor A and factor B. Okay, collinear points. If I have 3 points A, B, and C, and if A, B, and C lie on a straight line, then apply this formula where factor AB equals K. K is the scalar number, multiply with factor AC. Okay, as you can see in this picture, like AB and AC is in the same line, so it has the same direction. Okay, it has the same direction with different length. Okay, that's why factor AB equals K scalar multiplied by factor AC, or factor BC equals K multiplied by factor AC. Okay, this is how to prove if 3 points are collinear or in the same on the straight line or not. Okay, ratio theorem. Okay, let's just say that I have a point B, P, and A on the same line. Okay, B, P, and A on the same line where BP and P, the ratio of BP and PA is N to M. Okay, N to M. Okay, the position factor of B, OB, is this one. The position factor of OP is this, P with a small letter. The position factor of OA is A. Okay, this is how to find the position factor of P. Okay, before we get to that, okay, let's see. Based on this picture, OP equals to OB plus BP. Okay, OP, if you want to move from O to P, we move from O to B, OB, and then continue to B, from B to P, BP. Okay, so OP equals to OB plus BP. Okay, remember that BP equals to N divided by M plus N BA. Okay, since the ratio of BP is N and the total ratio is M plus N, so BP equals N divided by M plus N BA. Okay, now I change the BP to this. Okay, in the previous lesson, we learned in displacement factor that BA is equals to A subtract by B. Okay, so replacing all of this factor with its position factor, we get P equals to B plus N plus over M plus N, A minus B. Okay, simplifying this form by equalizing its denominator, we get this. Okay, this one. Okay, I equalize its denominator to to simplify this fraction, and so we get this one. Okay, thus we get the formula for position factor of b equals to this: n multiplied by a plus m multiplied by b divided by m plus n. Okay, this is the factor position of b, where p is in between of b and a. Okay, this is the ratio theorem. Okay, to measure your understanding about the lesson that we had, I want you to do the examples below. Okay, but you don't have to submit your answer in Scholar. Okay, it's just to know whether you understand the lesson or not. Okay, have a nice day. Bye.